Hi, my name is Shuwen Fang, and this is my video presentation for course Introduction to Systems Engineering. So the topic of my project is the case study of 5G system. First, here is the outline. First, I will briefly introduce the 5G system and why did I choose this topic. Second, I will use some method in the system lifecycle model to analyze the system. The first stage is the concept development stage, which will include the needs analysis, concept exploration, and concept definition. And then is the second stage, engineering development stage. In this stage, there are two parts. First is the advanced development, and the second one is engineering design. The fourth part, we came to the post-development stage. In this stage, I will introduce two parts of the system. One is production, and the second is operation and support. Next, we will talk about some challenges we faced in the 5G system. Six is the summary and conclusion. Also, I will talk about the lessons I learned in this project. Finally, is the references. To choose 5G system as my project topic, there are two questions jumping into my mind. First, what is 5G? And second one is, why do I choose 5G system as my topic? So for the first question, 5G is an abbreviation of the fifth generation technology. It's a standard for cellular networks. So why do I choose 5G as my case study topic? First, the telecommunication system is a sophisticated but critical system in our daily life. Everyone needs to connect to others or get internet services through our smartphones. So it's everywhere in our life. Secondly, 5G is a brand new technology which just began deploying worldwide in 2019. So there are a lot of area to be explored. Next, let's take a look at the history of mobile network system. In 1980s, the mobile cellular network started to develop from the first generation wireless technology, which is 1G. So 1G is only an analog standard that can only transfer an analog voice, and it applied FDMA technology. About 10 years later, 2G emerged. This technology used TDMA, which is time division multiple access technology. And 2G improved the analog voice in 1G into digital voice. It also provided other services like text message. Next comes the 3G. So in the 3G system, the technology used is CDMA, coding division multiple access. And in the 3G system, multimedia services are supported. and the network speed also greatly improved. By using the 3G technology, more and more uh, multimedia is available. For example, voice, text, picture, and videos. Next, 4G improved the network peak data rate to another level. The highest network speed could reach 1 gigabytes per second. But although 4G is widely used in in our life, there are still some requirements to improve the 4G system into 5G system. Now, let's start to analyze 5G system using methods we learned in class. First, the very first stage of concept development is needs analysis. For the development of 5G system, there are three main requirements, which is also three things we need to improve from the previous system, 4G system. Number one is the demand for a higher network speed. 5G network could provide enhanced mobile broadband in which the network speed could be as high as multi-gigabytes per second. And this great capacity can support some applications like 3D videos and 4K or even 8K Ultra HD video streaming. Number two is the need for massive machine-type communication. This is the only way to implement IoT, which is Internet of Things, because there will be millions of end devices communicate with each other. So 5G can solve this problem, and 5G could complete the data transmission between these millions of end devices. So it can help build a smart home or even a smart city. Number three, in the previous network system, say 4G system, the network connection could be unreliable, and there is long latency, which is not acceptable for some real-time applications like voice over IP or video conferencing. But here 5G provides ultra reliable and low latency communications. This could help the realization of industry automation, self-driven car, VR, AR technology, and remote surgery. To start the next phase, concept exploration, I divided 5G system into two subsystems. One is radio access network subsystem, and another is core network subsystem. For radio access network, there are two ways to implement: SA and NSA. SA stands for standalone network, and NSA stands for non-standalone radio access network. First one, SA, means that it uses only a single radio access cell, NR or LTE. Here, NR represents new radio, and LTE is long-term evolution, which is applied in 4G system. Second one, NSA, means that it will combine these two technologies together. For core network subsystem, there are also two types of network. One is EPC, Involved Packet Core, and another is 5GC, 5G Core Network. EPC is based on the traditional packet core network, which is used in 4G system, and 5GC, 5G core network, is a brand new technology. It has a cloud native, so implement 5GC could reduce the cost for physical resources. A clear understanding of subsystems and their functions could help us conduct the concept exploration and prepare for the next stage. So the next stage is also the last phase of concept development, concept definition. Here the graph shows several deployment options for 5G system. For example, if we're using SA radio access network, here we can choose either NR new radio or LTE technology. And if we choose SA as our radio access subsystem, the core system have to be 5GC, because if we use LTE with EPC, that will be just the traditional 4G system. But if we choose NSA as our radio access subsystem, which means the LTE and NR technology will operate together, then the core network subsystem could be choosing from EPC or 5GC. Each method has, so here we can see there are 5 combinations for 5G deployment options, and each method will have its own advantages and disadvantages. For example, if we use LTE as a radio access method, the LTE is long-term evolution, and this technology is already applied by 4G system, so we can leverage the existing LTE employments. This way, the cost will be reduced. However, NR new radio technology could provide a better performance. It could provide a more reliable connection and a higher network speed. So here is a trade-off between the performance and cost. And also for the EPC network and 5GC core network, the EPC is based on the packet core network, which is also applied in the previous system, like 4G or even 3G system. So we can leverage the existing infrastructure, but it will not provide a performance as good as the new technology 5GC. So one should choose the implementation method according to his or her requirements and also the constraint. By conducting needs analysis, concept exploration, and concept definition, we complete the first stage, concept development stage.